Hello dear students, I am P. Madhara, lecturer in physics in continuation of video lectures. Today we are going to discuss about capacitors. Now in this capacitors we need one question will come from this chapter. So first we'll have a look about the formulas. When three capacitors are connected in series, we have formula 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3. In case of capacitors connected in parallel, C is equal to C1 plus C2 plus C3. Then suppose if A is the area of the plates, D is the distance between the plates, then capacitance is given by epsilon naught A by D. Now A is the area, D is the distance between the plates. Next, energy stored in a capacitor is given by formula half CV square, Q square by 2C, QV by 2. And these formulas we are going to use depending on the situation. Suppose a capacitor is charged to Q, C is the capacitance, you have to use this formula. Suppose a capacitor having capacitance C, potential V means you have to use this formula. Only charge and potential given means you have to use the other formula. Now the fifth formula is capacitance with the dielectric constant K. Suppose this is the parallel plate capacitor. You are keeping a dielectric in between the plates. K is the dielectric constant. Then K is you keeping a dielectric in between the plates of the capacitor. Then we have C is equal to epsilon naught A by D by T minus T plus T by K, where T is the thickness of the dielectric, K is the dielectric constant. And now for this for conductors dielectric constant is infinity. Remember all the time, for conductors K is infinity. For metal plate K is infinity. So C is equal to epsilon naught A by D minus T plus T by K. No, the K is infinity. You have 1 by infinity is 0. Okay, like this you have. Now regarding the problems here, you have one problem here. Here a capacitor of 2 microfarads is charged as shown in figure below. When switch S is turned, S is turned towards 2, then the percentage of energy dissipated is. Now in this case what you need to do is you have to use this formula. See, this is the problem 1 and 2. You have the capacitor values as here 2 microfarads, here 8 microfarads, you got 2 and 8. Now so you have to use this formula. Initial energy is equal to Q square by 2C. Q square by 2C you have to use. Now what is the capacitance given here? 2 microfarads. No? Q square by 2 into 2, 4. Now this, if you switch it to second side, both the capacitors are connected here. In this case only one capacitor. If you switch it to 2 position, no, S is turned towards the switch is turned towards the second position, means here both the capacitors are connected. Then total capacitance how much here? Total capacitance in the second case will be 10 microfarads. So in that case final will be q square by 2c, that is q square by 2 into 10, q square by 20 you got. Now energy dissipated is given by formula initial energy minus final energy by initial energy. So into 100 you have to do. So what is the initial energy you got? Q by 4 minus q square by 20 divided by q square by 4. So throughout this q square can get cancelled. So what you are left out here with 1 by 4 minus 1 by 20 divided by 1 by 4. So if you go for calculation here, what do you have? 20, 5 minus 1 by 1 by 4. So here, if you simplify here, what do you get here? That is 4 by 20 into 4 by 1. So into 100 you got. Percentage means into 100 you should take. Into 100 you should take. So 16, 4 5s are. So it will be 80%. Answer is 80% you got. That is second option. Once again see this problem. A capacitor of 2 microfarads is charged as shown in figure below. When switch S is turned towards the 2 position, and then percentage of its energy dissipated is. So in that case, we have used this formula q square by 2c, capacitance 2 microfarads, 2 into 2c, q square by 4. Now again here q square by 2c, second case 2 and plus 8, 10 microfarads capacitor, q square by 2. You are dividing now, need not convert anything, microfarads you can keep as it is only. Then on simplification you got here like this, 80% is answer. This is the first problem. Okay. See this concept here. Capacitance, only single capacitance in parallel. Energy stored, since it is given charged here, we are using this formula q square by 2c. Okay. Next problem. Next problem is a capacitor is charged by a battery. Charged by a battery. The battery is removed. The battery is removed. And another identical capacitor is connected in parallel. Connected in parallel. Then the total electrostatic energy, energy of resulting system A decreases by 2, decreases by a factor 2. B remains same. C increases by factor 2. D increases by factor 4. Okay. Now in this case, in this situation, so here first what is initial energy? Initial energy is half CV square initial. Now this capacitor is connected to uncharged capacitor here. C and C is uncharged here. Notice connected. Now in this case what happens? There will be common potential. Charge keep on flowing here into the other capacitor. Because this A, this B considered same capacitor, no? Uncharged it is connected now. So charge give till the potential become equal. So you should take common potential formula. C1 V1 plus C2 V2 by C1 plus C2. So here you could take C into V will take here. C and C both are same only. Other one is 0, no? Other potential is uncharged now. So here V is 0 here. Uncharged means V is 0. Now here it will what you get here? CV by 2C you will get. That is V by 2 you will get. Now he is asking final energy now. So when he is asking final energy, what you should do now? Half into C plus C how much? C plus C 2C. Now potential here how much potential? V by 2 whole square. V by 2 whole square. So if you take like this, U final is equal to, what do you have here? Half C 2C into V square by 4. So 2 to cancel. So what do you get here? Initial final energy is equal to half into half CV square. So what do you get here? He is half square initial, no? So potential energy of the system Ui by 2 will get. So decreases by a factor 2. This is the option. See this question again. A capacitor is charged by a battery. The battery is removed and another identical capacitor is connected in parallel to it. For initially you got a capacitor and a battery. Now battery removed. Now battery removed, another capacitor is connected. Now is asking electrostatic energy of the resulting system. Finally what is happening? So initially half CV square you got. So this is the situation, the first case. Second case, what you have got? Again another capacitor you keeping. Whenever you connect another capacitor, no? Uncharged capacitor means potential is 0 here. So these two are parallel. So you should go for common potential formula. So C1 V1 plus C2 V2 by C1 plus C2. So C into V you have already, this is 0, no? C into 0 by C plus C. So what you are left out here with V by 2 you got here. Now resultant system, final capacitance is here half CV square. Total capacitance how much you got here? 2C, C plus C 2C. What is resultant potential you got? V by 2. V by 2 whole square will take. So half 2C into V square by 4. Cancel out. So initial energy how much you got? Half CV square. Half CV square into half extra you got. Half into half CV square. That is Ui by 2. That is initial energy. Energy decreases by how much factor? 2. Decreases by 2. Option first is correct. Okay. Third one is first option. Right. And next question. And these questions will be some tricky questions will be there. Not all the time you find difficult questions. Some easy questions will be there. There should not feel tension. They go for basic level only. All the time they ask basic questions only. So basic formulas like suppose the potential is constant. What happens to electric field? You know potential constant means E is equal to dV by dx. For constant differentiation is 0. So in that case, what is electric potential? Electric field means what? 0. So like that one question is there. So need not apply every time formulas and get the answers. Sometimes there will be logic in tension moment. You may go wrong in some questions. Some easy questions you miss out. Now third problem. In a certain region of space, in a certain region of space, with volume 0.2 cubic meter, the electric potential is is found to be 5 volts throughout. Then the magnitude of electric field in this region is, now you know you have basic formula, E is equal to dV by dx you have got. So here E is equal to dV by dx minus dV by dx you have got. V constant means constant differentiation will be 0. E is 0 only. Answer is 0 only. A option 0, B 0.5, C 1, D 5. So always remember this is a basic question. Potential constant means electric field will be 0. Suppose you get a spherical conductor. Inside electric field 0. Potential will be constant only. Throughout potential will be always constant only. Okay. This is the point.